this thing has been very difficult to make. That's the only thing I have to say. Okay, here's the deal. To be honest with you, my mission hasn't changed a thing. I still want to make a cooking robot because, well, we're lazy. Absolutely, I do not like cooking. So, this little sensor here, I am wanting to make it because of two reasons. One, because this robot that I want to make, I want to get it to have hands. And in order for me to understand the position of the hands or of the robot, I want to have something that can sense that. And yes, there is other ways to be able to sense the position of an angle of something, right? Established ways. But like I said, I'm a lazy bastard, and this sensor will, if I were to make it successful, I will be able to line it around the joints of this robot that I'm wanting to make, and honestly, I won't need to construct anything more than making a rope of these little sensory components and then just line it up onto the joints that I want to sense, and boom, I have the data that I care. So we're gonna try to make it. We're gonna try to make what I have here into a suit, and hopefully it can be cheaper. I also want to do one more thing with this sensor. I want to have, if I were to make a suit of it and if I were to wear it, I would like to be able to make certain posture or gesture and trigger a command, a computer command, and I'm able to control things. That's what I want to do. That's what I'm trying to get at with this sensor. So not only am I making it for the robot, but I'm also making it for me to wear and be able to control possibly the robot and also other things. I'm a visual person. I like to visualize things. And when I model things on this computer, I would like to interact with the models. And if I had a sensor onto my body that can cause me to interact with the model, I don't know, it creates a different depth of understanding of the thing that I've just created. And I think a lot of people will benefit from this as well. So in the spirit of that, I gotta do what I can do to make this thing a reality. This here is a list of things that I wanna make. Things that I want to get a hold of, things that I want to get my hands onto. And there is metal 3D printing. Just trying to metal print, it is hard. The machine that do it, they are in the $50,000 mark, which is a lot. So we're not going to think about that. But I will definitely like to be able to create some parts into metal. I mean, if I want to, for example, make the skeleton of this imaginary cooking robot, I would like it to be made out of something strong, that is rigid as well. And metal seems to serve the purpose. The question is, how do I get a metal part? I can always try casting. Next thing, motion sensor, which is the sensor that I've been working countless times on. The plan is that I want to create a suit out of this sensor. I want to make a full-on human suit. I don't want to just create gloves. I want to create everything, the gloves and all. Like, I want the sensor to sense every joint in my body. So every time I move, I'm able to capture those positions into a computer, real time. I guess I never really explained how the hell I'm gonna do that. I mean, I explained about the sensor, but I didn't explain about how I'm gonna get this information into the computer. Well, this is an ADC. The thing is, it's an insanely fast ADC. I'm able to get information from the sensor connected to this ADC. Through the SPI interface, I am able to communicate with this ESP32. It has a very specific module, so it's ESP32EVB. This is the brain of the whole system. What happens is that the ADC interprets the signals that it gets from the sensor. The information from this ADC gets sent straight to the ESP32. It broadcasts this information through this antenna into a local network. And any device that connects to this local network will be able to use that information to do what you commanded for those devices to do. Let's move on to the next one. Number 3 is artificial muscles. Well, in this case, I'm trying to make an artificial muscle controller. This here is an artificial muscle controller. No matter of fact, I'm gonna demonstrate it. Now all that happens is that these little rods here, they will move up and down. That's all they do. They move up and down, and whenever they move up and down, they will cause different pressures to go through this chamber here, at the bottom here. And that will be connected to a muscle like this. I like to call this a diaphragm muscle. This is how. So whenever air or fluid, I will much prefer this to have, whenever the fluid goes into here, it expands the diaphragm. And whenever that happens, it will be basically relaxing the muscle. But when this rod, this little thing, goes down, it will cause a different chamber to be exposed into this muscle. Basically, that chamber is the negative pressure. Yeah, it's basically the negative, the opposite of what the first chamber was doing. And whenever this rod gets pushed down, that will get to be exposed to that chamber. And whenever it gets exposed to it, the pressure or the fluid that is in there gets sucked out and causes this effect. And that's it. And whenever that happens, it moves a couple of centimeters. Whenever this happens, this little string, which I will call a tendon, it will be able to contract, move something basically. And which is no different to how our hands or body or basically anything that our muscle do in our body do. So this will be the new muscle. It's actually very easy to make, to be honest. The only tricky thing about it is trying to figure out the correct flexible material that can survive high pressures and also won't really destroy itself whenever it's moving like this. That's the one thing that I need to figure out. But what I haven't really done is put them under an actual experiment. Now, there is also this thing here. This is a screw pump. Essentially all it is, if you can see it, there is a couple of, well, screws. They spin around and this little thing provides the motion between these 3 screw pumps. So whenever this little thing spins around, it will provide motion to these 3 screws. And whenever they start to screw, any fluid that is on the bottom will then be squished up through the little holes that you see here. And then this is going to be a chamber, by the way. So the fluid that will exist here will be pushed outward and it'll go into here, and that distributes the fluid into the appropriate muscles. And how I do that is that I'm gonna use little motors like this. This is a motor controller that controls a bunch of servo motors. This is continuous servo motors. So what I'm gonna do is that I am going to get the servo motors to be connected to this thing. I'm gonna print a bigger one of this fluid distributor, and then these servo motors will be connected to it like this. And then whenever they spin, they will be able to push this rod up and down. The last part, the last final part, is the spider cam. The spider cam, assume if you've watched any of my previous video, is basically this little box thing hanging with some strings. That's basically what it is. But I had great visions for it. I'm gonna make sure I try to make it true. Everything that I've mentioned previously, it all adds up onto that little piece of technology. It's gonna still be a box. There is no denying that. It's gonna have hands on the side of it. And then there will be a camera, you know, so you can see where it's moving. And every technology that I've worked on will be incorporated into that little spider thing. I don't really intend it to be the actual cooking robot. The actual cooking robot will be a humanoid robot. Now this, okay, I mean, I'm listening to myself speaking about making a humanoid robot, and I find it just crazy to think about it, because it sounds like a difficult thing. And not to mention, there is a bunch of thousands of people around the world trying to do the same thing who are way smarter than me, and yet I am in the same realm as them. Like, I'm wanting to make a robot, especially this complicated. There is no lie, I am not gonna do this alone. In the future, honestly, I am gonna try to find people who can join this journey. That's the one truth. But the one thing I need to do is I need to prove this to myself, that I can do it. It's not about the knowledge that I have. It isn't. It is about the efforts that I put into it. What was I on about? Yeah, the spider cam. It is gonna have the metal printing technology into it, because I gotta make like the skeleton of the whole robot, the hands, the structure of the spider cam. Next, the motion sensor. I need to be able to detect the movement of the hands. So the artificial muscle would exist to control the hands themselves. And this is basically the thing that makes me feel like I can't make it. I can't make this robot. The thing that makes me feel that is the idea of making this thing a reality. Because I believe if I can make this a reality, this is more than halfway done. The one tricky thing about making a robot is, how do you move the damn robot? It's difficult finding the actuators to do this. Motors, they can do, but they're difficult. They're basically a thing that is not built for the task. So this is something to control lots of mechanical muscles. Like I've stated in my previous video, I tried to design something that could control lots of mechanical muscles, but now I have settled into a solid idea. That idea evolved, and this is what it involved too. In fact, I have a demonstration of this. So this makes me believe that I can make this robot. Of course, if I put in the effort to do it. Well, let's find out.